Hello everyone! In the last video we had a look at upward opening and downward opening parabolas. This time we're going to focus on the vertex, and specifically how we can calculate where the vertex is. I will start by pointing out how we are going to use symmetry to find that vertex. Then we will get to the actual steps of calculating the vertex. And lastly we will have a look at a specific case where we are going to use the points of intersection with the x-axis to calculate the vertex. Alright, so we have this parabola and we want to know the vertex. As I said, what we're going to do is we're going to be using the symmetry that a parabola has, because the axis of symmetry always goes through the vertex. Which means if I have 2 points on a parabola that are at the same height, then my vertex is going to be right in the middle. The easiest point to do that with is at the height where it intersects the y-axis. So that is the method that we're going to use. So let's have a look at how this works. This parabola has the function f of x equals x squared minus 5x plus 3. And as I said, the first thing we want to know is where does it intersect the y-axis. Now this is where x is 0, so we're going to fill in x equals 0. You may already realize if x is 0, then this whole thing disappears and this whole thing disappears. And we're just going to end up with this number, so this happens at 3 in this case. Now that we know that, we want to know the other points in our graph that intersects that. My circle was not at a very nice height, oh well. But we want to know the second point. And we do that by setting our function equal to, in this case, 3. So we get x squared minus 5x plus 3 equals 3. And this is an equation we have to solve. And with quadratic equations, what we usually do is we rearrange it to 0, which in this case means minus 3 on both sides, or having these two cancel out. So we get x squared minus 5x equals 0, and it reduces to just a binomial, 2 terms. And with this specific method, this will actually always happen, which means we can factorize fairly easily. Because factorizing, we just get x times x minus 5 equals 0. Which then tells us that x equals 0 or x minus 5 equals 0. So x is 0 or x is 5. So x is 0 we already knew. And then the other point is that x equals 5. From there we find the x value of the vertex by taking the middle, the average of that. So that would be 2.5. If you want to use an actual calculation, well, it's just 5 divided by 2 in this case, but more generally it's the average of the two numbers. So adding the numbers 0 plus 5 and then divided by 2. We've got 2.5 here. Then of course we also need to know the y value to actually get the vertex. And to get y, we just need to fill in x in the function, so f of 2.5. Filling that in, I used brackets to be extra clear to be sure, but that just gives a calculation you fill into your calculator, which tells you that y equals minus 3.25. And then we can conclude that the vertex is at 2.5, minus 3.25. So there's a lot going on. Let's just recap what we actually did. We started by finding the intersection with the y-axis, which we did by filling in 0, or just using that last number in the function, the only number without an x. After that, we've calculated the other point that is at that same height. And we did that by setting the equation equal to whatever number we just found, in this case 3. That gives us 2 points where the graph was at that height. From there we calculated the x value of the vertex by taking the average, the middle point. We followed up with the y value by filling in our x in the function. And then last but not least, we drew our conclusion. So this is one method, and this is the method you're usually going to use. But occasionally there will be another method that's useful, and that is using the points of intersection with the x-axis. This is only going to be useful if your function is already factorized or otherwise very easily solvable. So what we're going to do is we're going to try to find these 2 points instead. Then the vertex is still going to be in the middle of those. We almost have a smiley face with those 2 little circles, and the parabola is a smile. Anyways, how do we find those 2 points? Well, those 2 points both occur at y equals 0. The x-axis is y equals 0. So we set our whole function equal to 0. And here you find where this is so useful, because our function is already factorized. It is equal to 0, so we can just say that one of these parts is equal to 0. X minus 2 is equal to 0, or x plus 1 is equal to 0. So x equals 2 or x equals minus 1. And from that, to find our vertex, which is going to be right in the middle, we add the 2 numbers, divide by 2, to find the average. 2 plus minus 1 divided by 2, we get 0.5. Now that we have our x value, all that we have left to do is finding the y value, which works the exact same way. We fill in x into our function. So f of 0.5. And this is yet again just a calculation that you fill into your calculator. And this time you'll find that y equals minus 2.25. So the resulting vertex is at 0.5, minus 2.25. Again, let's go over what just happened here. We started this time by finding intersections with the x-axis. We did that by setting the function equal to 0. After that, we found the x-coordinate of our vertex by calculating the average of the 2 points we found. Then we followed up with the y-coordinates by filling in the x into the function. And last but not least, we drew our conclusion. So as you see, there are this one has 1 step less than the other method. However, this only works because this equation at the beginning was so easy to solve after we set the function equal to 0. So this generally only works if the function is factorized. If it's not, there may not even be solutions to the equation at all. So then this method would be completely impossible. Therefore, you should be able to use both of these methods, and actually the first one is more important, and use them when appropriate. So that is all I had to say for now about the symmetry and vertex of a parabola. I hope this helped you calculate the coordinates of the vertex of a parabola.